Good morning, students. Today our topic is Python pandas, and in this lecture we are going to discuss some program related to Dataframe. Our first program is how to calculate standard deviation variance in a given data frame. So first of all, we should aware the concept of the standard deviation variance. You can easily see on the screen that is the formula given on a screen. So as far as variance is concerned, variance is nothing but only the average of the square difference from the mean or a particular given set of data. And standard deviation is a measure of how spread out numbers are, and standard deviation is represented by a Greek letter sigma. And we can also say that it is the square root of the variance. So standard deviation nothing but only the square root of the variance, and you can easily see the formulas and terminology which represent variance and standard deviation on a screen. So S square is variance, xi is the terms in the data set, x bar is the sample mean, sigma is the sum, and n is the sample size. And the formula is S square is equal to sigma xi minus x bar whole square upon n minus 1. That is the formula to calculate sample variance. So I think all of the term are very clear to all of you. Here the sample is divided by n minus 1 when calculating variance. It should be noted that. And second thing is, in terms of the population, it is divided by n when calculating variance. So formula of variance vary, and we take the population, then we divide it by n, and we take a sample, then we divide it by n minus 1. Now let us see the program to calculate standard deviation and variance. For calculate variance, we have a simple method var. So we just write name of the data frame first, then after put dot operator as usual, and then name of the method, that is var in this case, to calculate variance. So that is a program based on standard deviation and variance, or to calculate standard deviation variance. So first of all, at least we have some data. On behalf of that, we can easily calculate a standard deviation variance. So you can easily see that so first line is import pandas as pd. Before this, there is a statement, print statement, which shows the purpose of this program. Simple standard deviation and variance shown below. So first line is import pandas as pd, because pandas is a very essential library which is to be import if we want to calculate standard deviation variance using a data frame. And pd is the alternative name given to pandas library. So if we want to use pandas as a library, we just use pd. After that, put dot operator and then name of the method. So this is a program which calculate standard deviation variance along axis 0 and axis 1 of a particular given set of data. Now this is the program. So first line import pandas as pd. After that, import numpy as np. Numpy is a library which is required in this program, so we just import this library with alternative name np. So instead of using numpy, we just use np in place of numpy. And then there is a declaration of a list. So list contains different elements 1 9 5 6 8 7, and then we just print this list, and then we take a standard deviation. Always remember that for standard deviation there is a method named std. So we pass data set, or we can say that a sequence, as a parameter value, then we are able to find out the standard deviation of particular sequence. For example, you can easily see that there is a statement print np.std, which basically calculates standard deviation of dataset D1, which is a list in this case. And to calculate variance of dataset D1, there is a method named var. So var is a method basically used to calculate variance. So we just pass a parameter value or D1, which is of course a data sequence or a list. Then we are able to calculate variance of D1. So two things are there. First of all, we just declare a list here. First of all, because we want at least a data set on which we can easily calculate standard deviation variance. Second thing is, for to calculate variance there is a method named var, and to calculate standard deviation there is a method named std. Third important thing is that we just pass this data sequence as a parameter value within that method. Then we can easily calculate standard deviation or variance of the particular data set. In next case, you can easily see that we just take a data set D2 which also contains some negative value. So same procedure followed for this data set also, or this list also, and we just calculate the standard deviation using std, but pass as argument d2 here, or pass as a parameter d2 here. For variance, we just write np.var and pass parameter value d2 here. D2 is a sequence. So there are two different lists. One contains a positive number, one contains a positive and negative number, and here we just easily calculate the standard deviation and variance using method std and var. So now if you want to calculate a standard deviation or a variance for a data frame, so first of all we have to create a data frame. Now in this case, d is the name of the data frame. You can easily see in a scheme where the statement is written as d is equal to, and then there is a sign of curly braces in which name, score1, score2, score3, these are the basically column name of the data frame, contain different data elements. For example, name contain Bharat, Aman, Ravi, Divya, Satya, Rahul, Ajay. So these are the name of basically the columns of a data frame. And similarly, there are some values regarding to the column name score1, score2, score3, etc. And then thereafter simply a print statement, print data frame is. Now we have a data frame now. Now we have to calculate standard deviation of that particular data set. So simply we just do simple thing. We just write name of the data frame, which is df in this case. So just write df first of all, and then after put dot operator, and then just write name of the method, that is for standard deviation std and for variance ver. So to calculate standard deviation, we take a variable std1 is equal to df.std, and to calculate variance we just use a variable ver is equal to def.ver. So in this manner we can easily calculate standard deviation and variance. But there are two axes, axis 0 and axis 1. By default, standard deviation and variance are along axis 0, but if we want to calculate it along axis 1, then we have to mention axis is equal to 1 as a parameter value. Axis 0 means column wise and axis 1 means row wise. So you can also pass a parameter value axis is equal to 0. By default, axis is equal to 0. It means column wise standard deviation or variance will be calculated if we use the formula if we use the method std or var. And if you want to calculate standard deviation or variance along axis 1, then for that purpose we just write std df.std, and where df is the name of the data frame, and within parenthesis just write a parameter axis is equal to 1. So one thing should be noticed, that if we don't pass as a parameter value axis is equal to 0, then by default it is axis is equal to 0. It means it will calculate the standard deviation or variance along axis along column or along axis 0. For calculate standard deviation there is a method std, and for calculate variance there is a method named var. So these are the two methods. And so this is a formula, this is a program here. Now we can conclude this program. Basically in this program we take two lists and one data frame. and one list contain negative numbers and one list to contain only positive numbers. So if we want to calculate standard deviation using this list, we can use the formula we here just use the formula std and ver for the list, and for data frame we again use the formula std and ver, but in case of the data frame we have to mention x is axis. By default x is equal to 0 because data frame have two axes. By default x is equal to 0, it means standard deviation variance should be calculated along along column or along axis 0. But if we intentionally declare this x is equal to x is equal to 1, then it should calculate the data it should calculate the standard deviation and variance along row or along index. Now you can see the output. It gives you basically clear idea about this program. First of all, there is a print statement. We just write in it that is simple standard deviation and variance, and then there is a list. There are basically two lists, and then we calculate standard deviation and variance for these two lists or for these two data sequence. And then okay, now you can easily see on screen. So these are the two lists, list 1 and list 2. We just calculate simple variance of data d1, and second list calculates standard deviation. So we just calculate standard deviation and simple variance for data for list d1 and for list d2 here. I just take two lists here because one list contain only positive value and second list contain both positive as well as negative value, to show the clear functionality of standard deviation and variance. You can also calculate them mathematically and check the answer. That is it and check that is it same or not. So now the second case, in terms of the data frame, if we want to calculate standard deviation, so first of all we have to create a data frame. So data frame is there, you can easily see on the screen, which contain column name, score 1, score 2 and score 3. These are the name of the this is our data frame here. You can easily see on the screen different columns name are there, name, score 1, score 2, score 3, and different index values are there. Basically these are the default values, start from 0. And now standard deviation of the data frame, you can easily see that it is column wise. So score 1, score 2, score 3 are there, and when we calculate it just along axis 0, result is same, means by default standard deviation and variance will be calculated along axis 0. Will be calculated now you can easily see on the screen. First standard deviation and then second variance. Column standard deviation is same as that of the default variance because axis is equal to 0 is given in this case, and row standard deviation of the data frame is given here, which is different from it is different from the column variance or standard deviation. It is basically along axis 1. So you can easily see that name of the index of the rows are given here, 0, 1, 2, 3, 4, 5, 6. Same manner row variance of the data frame is also there. So this is the program to calculate standard deviation and variance. The most important thing is that to calculate standard deviation there is a method name std, and for calculate variance there is a method name ver. In case of data frame. If you want to calculate it along axis 1 means row wise, then we should pass it as a parameter value. Now our second program is related to quartile. So first of all, let us take a brief discussion of quartile. Quartile are the values that breaks up the data set into quarters. That's why they are called the quartiles. And there are the first four parts, and the first quartile is the point below. Sorry, quartiles are the value that breaks up the data set into quarters. So the first quartile is the point below which a quarter of the data lies, and it is sometimes called as the lower quartiles. So there are the three quartiles: lower quartile, median, and upper quartile. And second is median. So the second quartile is the point below which half of the data lies, and third quartile is the point below which 3/4 of the data lies, and it is called the upper quartile. So basically quartile divide the data set value or break the data set into quarters, and there are three quarters. First quartile, second is median, and third is upper quartile. So more generally, quartiles are cut points that divides a sample data bit into subgroups. For instance, if we say that 2.0 quantiles equal to 5, that means that 20% of all observations are less than or equal to 5. And while the other 80% of the observation are greater than 5. So that is the meaning of a quantile. So let us take a program here to show the functionality of a quartile. This is different from the term percentile, which is most commonly used in mathematics. The quartile basically divides data into subgroups, and this is a program here. First of all, we should create a data frame, and then we can easily create a we can calculate quartile by the formula, by the method quantiles, Quantile. So now you can easily see in the screen, df is the data frame, and there is a creation of the data frame, pd.data frame, and there are 4 columns A, B, C, and D. And then after that there is a print statement, print the data frame. So here just we just create a data frame to calculate the quantile. Now the important thing is that if you want to create first quantile, so for this purpose we use the method quantile. So name of the data frame first, it is df, and then quantile, Quantile, and within the parenthesis we just give a parameter value 0.25 to create first quartile, and we should also mention axis, and if we don't mention axis, then by default it will be calculated along axis 0. So you can easily see on the screen, b1 is equal to df1 dot quantile 0.25, x is equal to 0. And to calculate median in second quartile, we just use the formula df dot quantile. Df is the name of the data frame, dot, and then quantile is a method. 0.5 is passed as a parameter value, and if you calculate it along axis 0, then just write parameter value x is 0. And to calculate upper quartile, we use the formula df dot quantile and pass 0.75 as a parameter value, and we want to calculate along axis 0, then we just pass axis 0 along axis 0 as a parameter value, and by default it also calculate it along axis 0. So if we don't mention axis 0, it will be calculated axis 0, it means column wise. And if you want to calculate or find out it along axis 1 means along row, then we should give axis is equal to 1. So I think very simple to understand. This is a formula. Basically, first of all, we create a data frame, and to calculate a lower quartile, upper quartile, and median, we just use a method quantile and pass 0.25 for 0.25 as a parameter value to calculate lower quartile, for median 0.50, and for upper quartile 0.75. By default, it will calculate the quartile in along axis 0 means column wise, and if you want to calculate it along axis 1, then axis 1 should pass as a parameter value within the method quantile. Now this is our answer. First of all, there is a data frame. Data frame is, so ABCD are the name of the columns, and the 5 rows are here. 0.25 quantiles on the axis 0 is there. You can easily see on the screen for different values of A, B, C, D. So along A it is 2, for along B it is 3, for along C it is 2, and along D it is 4. 0.5 quantile on axis 0 values are also given, are also calculated by using quantile method, then 0.7 along 0.75, and then axis along axis 1. So same procedure is followed for axis 1, but to calculate axis 1 we just pass as a parameter axis 1 within the method quantile. Now let's take another program. This program is related to group by method, and this method is basically group the data, and it is very similar to the group by function used in SQL, and that is also used in data frame group by method. So group the data on the basis of a particular condition. So for this program, we first of all we should create a data frame with repeated values, because if there are repetition values, then only we are able to create a group on behalf of that values. So you can easily see there is a data frame, there is a data frame D, there is a data frame. Okay, first of all a dictionary is created here, and this dictionary is passed as a parameter to create a data frame. This dictionary contains name and then exam, subject, and score as a column name, because these are the keys of these dictionaries, and values are given inside the list along these keys. So this is a simple creation of a data frame, and name of the data frame is D here. You can easily see that there is a repetition of values. For example, in case of name Aman Puneet Vishal, Aman Puneet Vishal, repetition is there. Exam semester 1, semester 1, semester 1, semester 1, semester 1, semester 2. These types of values are there. Subject mathematics, 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 science, science, science. So there is a data frame. First of all, we created simply a dictionary to create a data frame. After that, to create a data frame, we just write the statement pd.dataframe and pass this dictionary as a parameter value D. And if you want to name the column, then we can also use parameter value columns. By default, keys are plays as a role of a column in a data frames. So we just omit this statement, then by default name, exam, subject and score are the column names. Now till now there is a we just create a data frame. Now our main purpose is to group the data on behalf of a particular condition. So for example, if you want to calculate the mean of score of a particular student, of each and every student, then we just give a command here, as you can easily see that on the screen. And then if you want to calculate sum, then for that purpose just write a2 is equal to df score group by df name df exam sum, then that will calculate the sum on the basis of name and exam. So you can easily see on the screen, first of all, this is the output of this program. There is a creation of a data frame here. First of all, there is a data frame. You can easily see this is our original data frame, in which we can easily see that there is a repetition of values here. And if you want to calculate this sum mean marks of a semester wise or student wise, we can also calculate it. For example, in case of mean, you can easily see that mean mark average marks of each student, Aman, Puneet and Vishal are there, using group by method. And then sum of score group by name and exam are also there. Here we just use two different column name. Group by is the name of the method used to group a data. And third case, group the entire data frame by subject and exam score. So result is there. And if you want to find out the description of the data set, then it can also be calculated. This is a group the entire data frame by subject and exam score. And you can easily see that there is a description statics of group subject. It calculates mean, standard deviation, minimum, and 25% quartile, 50% quartile, 75% maximum. So this is the description of or the summary of the data. And we calculate here just because of the method name describe. You can easily see that describe. So here you can easily see that A4 is equal to df score So we take a column name score of data frame df, and then after put dot operator, then name of the method group by. So we make a group on the basis of subject, because we pass here subject as a column, subject as a parameter value, df subject. And if we also want to describe the data in detail, then we can also, and then we use here describe method. You can easily see that dot describe is there. So if you just use df dot subject, it basically group the data on the behalf of subject on data frame df of column score. So that is about today's lecture, all about our today's lecture. I hope now you are able to understand all this program. Thanks for watching this video.